Yes, all of it.
No. We all pass that back to.
Yeah, I like you not paying attention.
Yeah.
I forgot about it earlier. But I just couldn't find.
I'll look at it. I'll look. All right, questions about your homework? Anything?
Yeah. I don't remember.
4. 2A4, B4, C4. Nope, C2. A4. Bless you. You are right. Bless you. I need a printed out copy.
Oh, yeah.
AB -4.
Why don't we
What?
put it on the whiteboard?
2AB2. No. Here we go.
Yeah.
All right. Let's work inside first. I think that I will do this to everybody inside. And on the bottom, I'm going to combine together what needs to go together. So I'll do 2 things at once. So I get 2 to the 4th, A to the what? It was to the 4th, and I'm raising it. Oh, is that a negative? A to the what? 4 times -4 is -16. B to the -16, what's the exponent now on C? 2 times -4, -8. And on the bottom, I have A to the 1st, A to the 1st, and a 2. I'm going to put the 2 out front. A to the 2nd, B to the -2. I'm going to keep cleaning up, I think. Oh, look at that. Everybody's going to the bottom. Somebody asked about this yesterday, and they said, but if everything's in the bottom, what happens? Well, you just hold the place with a 1. So I end up with 2 to the 1st. Now 2 to the 4th is down here. I had A to the 2nd. Now A to the 16th is down here. I had B to the... Ooh, no, wait, I lied. This one comes up. B to the 2nd, B to the 16th, and then C to the 8th. So B to the 2nd over 2, 5, A, 18, B, 16, C, 8. Yeah. You don't have to. You can, or you can. There are multiple ways to do these. I always move them. Maybe you cleaned it up and left the negatives because you knew this was a negative out here, and a negative times a negative is a positive, and that's fine too. I end up with here 2 minus 16 is 14, right? But negative 14 in the top. So it leaves me with 1 over 2, 5, 8, 18, B, 14, C, 8. And all a -1 does, you can distribute it to everything, but all a -1 does is flip. It flips everything. So this would just become 2, 5, A, 18, B, 14, and C, 8. It just moves everybody up top. So anytime you see a -1, just remember all you gotta do is flip the fraction.
Look here. I don't know this again. Know what I'm doing. Gave up. Did half of it wrong, but I'm still ahead.
What else on your homework?
Like, so when you flip it, like, if it's a negative, it's like 2a -3. You only move the a to the top and leave it.
All right, if it's 2a -3 like this, then yes, this would be, the 2 would stay up top. The a is what moves
I
down.
looked and forgot that we had to like put the exponent on the big number. I didn't do that for like.
If the negative on the bottom, then you move it top.
Yes, that's
I
right.
didn't do that for like half of the whole.
So if it was this, that would be a3 over 2. The number in front doesn't move with it. Yes. I wonder if I can write on here like that. No. Let me hold some ice paper to it. Sorry, I didn't mean to jerk that away from you. Give me your paper. R0. 2p -1. Most of our problems are not this involved. 2qr and then 2. All right, I'm gonna start working inside. Then I'll move to the outside. Let's see. I think I shall do this first. And let's see what happens. I end up with 2 to the -4, q to the 8. I'm just going to go ahead and do away with that one because it becomes 1. 2p -1 q3 over 2qr squared. Let's see, I have 2 -4. I have p -1 q to the 11th over 2qr. I'm going to move it down, Oops. Sorry. And if you want to go ahead and do that now, you can. I tend to leave those till the last, but it doesn't matter when you do it. If I move this down and there's already 1 here, will that confuse anybody if I go ahead and put 2 to the 5th? No, Miss McKee, we're good. I've got a Q11 still up here. I've got a Q, an R, and of course that P came down. And the only thing I can combine here are the Q's. So I end up with 11 minus 1, which is 10. And then I've got 2 to the 5th, R. Now everybody can get that too. Here, 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 and here. So I end up with Q20 over 2 to the 10th, R squared, P squared. What else?
Hold up. How do we get 2, 5? Because wouldn't -4 plus like when you multiply the 2, that's not. Not yet.
4 plus 1. There was already a 2 down there.
No, I know, but I'm doing number 9, right? So wouldn't the 2's like multiply together and have the exponents like that?
No, you don't do both. If I have x squared times x to the 5th, I leave the base the same and add the exponents. Just because it's a number doesn't mean you combine them.
So if it, like, if that's
This is not x times x to the 7th. It's just x to the 7th.
Yeah, no, but like, go up really quick. I'm talking about that. You see how like it's 2 to the -4 times If that had a 1 on it, you would like.
But it does have a 1.
Yeah, no, I'm talking about the other one up top. There's like 2 3s up top.
Oh, I missed it. Dang it, Logan, you're right. This would be -3. Put that 3, which would make this 4. Which would make this 4, which would make this 8. You're correct. I apologize. You could, or you can leave it. It doesn't matter, whichever you want to do. For those, it doesn't matter. Yeah.
I didn't like the whole home. Because I forgot that you put the little X marks in it. Well, I did all the numbers right.
But you quick to find my mistake, ain't it?
Yeah.
I'll tell you what. What else? What else? 16?
I'm just helping the homie out, you know? We're not going to have time for a lesson today.
We definitely have time for a lesson. I'm going to try this little snippet.
Also, I need help on.
Okay. It won't paste. Let me see. I did.
Like 8 and 16, this will be gotta get it. Oh, cool.
I mean, when you snip it, it automatically goes to your clipboard. But yeah. It's snipping, but it's not pasting. I know there's a way to do it. It would be convenient to be able to do that. Okay, well, whatever. You said 16? 2xy cubed z4. Xy cubed. See, I should be able to write on here like I can though. Maybe that's what it is. All right, over 2x o y 3 2 times 2x 3y. -1 cubed. Everybody to the 3rd power. Let's clean it up inside first. We'll do the bottom. We'll leave the top alone, just for the time being, and I'm gonna do the bottom. I've got a 2 and a 2, which would give me 2 squared. X0 is just gonna go away because that's times 1. So I've got x3, and then how many y's? 3 plus -1, which would be 2. And then z's 2 and 3, which is 5. So I got 1 up top and 2 in the bottom. It leaves me how many where? 1 in the bottom. I've got 1 up top and 3 in the bottom, which will leave me 2 where? Top or bottom? Bottom. Wherever there's most is where it's leaving. Now, if you subtract, you get -2, and the -2 moves down. I'm just shortcutting it just a bit. 3 up top, 2 in the bottom leaves me 1 up top. 4 up top, 5 in the bottom leaves me 1 in the bottom. I've got a 3 here, and now that 3 is going to go to everybody. I got y3 over 2 to the third, x to the sixth is e to the third. These are very involved. You won't have this difficult on your test. This was just to challenge you and push you. Oh, come now. All right, let's do some polynomials.
You just grade out how much homework we're doing, right?
I grade yours if they're right or wrong.
Yeah.
I hold you to a higher standard.
This one's all wrong. Well, not all wrong. Some of it's wrong.
All right.
So, everyone's rookie word.
What's a polynomial?
Thing with many numbers,
Okay, not many numbers.
letters,
More than one what?
equation.
Actually, I'm going to say one or more what?
Equations, coefficients, variables. All right.
Terms. What are terms?
Things with letters.
Terms are monomials. We can write them. They have variables. They have coefficients. They have numbers. Things like 2x is a term. 5x squared is a term. Negative 1/2 x to the 10th is a term. So all of these, whenever we add or subtract them all together, make up polynomials. A monomial is a type of polynomial. So we'll talk about classifying them in just a second. Now, some things you need to know about polynomials before we start. All the exponents have to be positive whole numbers. Okay, so if I had 5x to the 1/2 plus 6x minus 3, that is not a polynomial because the exponent is not a whole number. Okay, so positive whole numbers on x's, as long as that's the case, we're good to go with being a polynomial. When we write polynomials, we write them in what, and if y'all already know this, and you probably do, so I apologize if you do. We write polynomials in what we call standard form. And just like with a quadratic, by the way, is a type of polynomial also, but just like with a quadratic, standard form means I start with the biggest exponent and I work my way down from there. So to put it in standard form, you start with the biggest and then you work your way down to the constant. So for example, maybe something like do we agree this is a polynomial? Yes. Because all the exponents are positive whole numbers, right?
Yes.
Y'all okay there?
Yes.
All right. Little more vocabulary before we get into adding and subtracting today. The biggest exponent is very important. That is what we call the degree of the polynomial. Standard form. We write it in standard form from the biggest exponent down. That 9 in front, does anybody know what that's called? What kind of coefficient? The leading coefficient. It's called the leading coefficient because when I am in standard form, it leads the equation. So that makes sense, right? How about this too? The not leading. What'd you say? No, what'd you say? Yeah, what'd you? That's exactly right. It's the constant. It's the constant because it doesn't vary right? There's no variable on there, so it can't vary. It is always constantly the same value it's 2. Okay? All right, so we've got leading coefficient, degree, and constant. Can you identify those 3 things in any polynomial that I give you? Okay. If not, speak up. Make sure you speak up and let me know. All right, we're going to use these. This is why I make sure you understand that vocabulary. We're going to use these to classify our polynomials. Y'all got that? Two ways we classify polynomials and give them names. One is by their degree. The other is by their number of terms. We'll do the degree first. If you have a polynomial of degree 0, so the biggest exponent on x, let's think about what that looks like for just a minute because that'll kind of help you. X to the 0, anything to the 0 power is what? 1, right? Do you agree? So if I had 4x to the 0, that would just be 4. It's still a polynomial, but it's what we call a constant polynomial because there's nothing else there. It's always the same. So if the degree is 0, it's a constant. That's the hardest one for students to see and understand. If the degree, however, is 1, what type of polynomial do you think that is? It's one you're very, very familiar with. Let me give you an example. 2x plus 3 is a degree of 1. But linear, that's exactly right. These are all examples of degree 1. It is a linear polynomial. What if I up it to 2? Another one you're very, very, a quadratic. That's exactly right. Guesses? Cubic. That's exactly right. Degree of 3 is a cubic. Ooh, how about 4? You probably don't know 4 and 5. 4 is a quartic, and 5 is a quintic. Past that, I don't make you know the names. We'll just call it a 6th degree polynomial or a 10th degree polynomial. But do be able to recognize up through the 5th degree. Now, I said we also classify them based on the number of terms that they have. Terms being how many things are added or subtracted. How many terms does this one have? 2. How many terms does this one have? 4. Okay. We will only do up through 3, and past that, we'll just call it a polynomial. So if it has one term, just one term, no matter what that term is, we call it a monomial. 2 terms, binomial. How about 3 terms? Trinomial. And then 4 and beyond, we just call them poly for many, polynomial. Now, a monomial is still a polynomial, a binomial is still a polynomial, a trinomial is still a polynomial, but they're right. So, I can have a linear binomial. Do you agree? Can I have a linear trinomial? How?
The degree just has to be 1. But
if the degree is 1, how?
You can have 2 terms that have x.
But then you would just combine them because they'll be like terms. The answer is no. In standard form. What an L. All right, let me give you a couple before we get into adding and subtracting. Yeah, that's all we'll do today. Maybe multiply. I had multiply. Dude, did I have multiply and divide? No, it's Wednesday. No, it's not. It is not Tuesday. It's Wednesday because I had training I was supposed to do this morning for delayed start. I got plenty of time. 19 minutes.
Okay, well, you don't want to go back to the 70s, do you? Or the 2s out of 20. Yeah.
Polynomial or no?
Go, come on.
Yes. Classify it by degree and terms.
Quadratic triangle.
It's a quadratic trinomial. What's the degree? Is it in standard form?
Yes.
Why?
Because it goes 2, 1, 9.
What's the leading coefficient? What's the constant? Everybody okay on that? If y'all are okay, I'm gonna move on because it's pretty. Because it's the degree is 2, so look at that little chart. Degree of 2 is quadratic. All right, let's add or subtract. Add, subtract is easy. And I'm not going to spend a long time on that because all we do when we add, subtract is we combine like terms. That's it. So, if I have something like those are not in standard form the way they sit, but that's okay because after I simplify it, I will put it in standard form. Like terms, remember what like terms mean? That means the same variable with the same exponent. I'm adding here, so what goes with what?
4x squared.
I've got 3x squared and 1x squared, which would give me 4x squared.
6x.
And then 11x and negative 5x gives me 6x. And then the constants there on the end, 4 and negative 13 and negative 9. Is it in standard form? Is it a polynomial? What kind of polynomial? A quadratic trinomial. What's the leading coefficient? Constant? Degree.
So wait, you don't have to do negative 9 for constant. 9.
What'd y'all say? Y'all didn't say negative 9? I thought you did. Negative 9. It's negative 9. How does it change if I subtract? Well, I just subtract.
Everything becomes the opposite of what you decided. Can I try again?
No.
Please? Can I tell you what I got?
When I do these, I always look through the whole problem and look to see if I can find the biggest exponent, and that's where I start. If you're a same, change kind of person, then you want to same, change everything in the parentheses that follows the subtraction sign, because this is saying that you're subtracting everything in here, not just the first term. So I might do something like this. Try on your paper.
I don't have my paper out.
All right, I've got an exponent of 3 in here, so I'm going to start with that one. There's only one, so I get y to the third. How about powers of 2? And then just the y, I've got a 5y and a y, which would give me minus 4. Huh? What? It's not. Leading coefficient. 1. Degree. Constant. -4. Classify the polynomial. It's a polynomial because it has 4 or more. I don't have a specific classification for that, so it's a cubic polynomial. Y'all ready to multiply? Yeah.
So why don't we like
We do. Leading coefficient's 1.
yeah, that's about what you do in the parentheses.
The 2 in the parentheses.
First y and then y.
Oh, there. We do.
So why isn't it 2y?
Because this was cubed, this is just y to the first.
Oh,
They're not like terms, right? All right, let's talk about multiplying. Y'all learned this is FOIL. I don't like FOIL because FOIL only works when it's a binomial times a binomial. So I call it distribute, and I think we have talked about this. If I have something like w minus 7 times w squared plus 2w plus 1. Instead of thinking FOIL, I'm thinking of, I'm going to take every term from this first parentheses and bop it to every term in the second parentheses. Okay? In other words, I'm going to start with w, and it's going to distribute through to everything here. So what is w times w squared? There you go. And w times 2w, remember those exponent properties, we're now adding the exponents here. And then w times 1 is w. Now I'm done with that first term. So I tend to mark it out so I don't lose my place. And I circle the second term. And now I do the same with that term. So minus 7w squared minus 14w. Now I can combine my like terms together. So I have w to the third minus 5w squared minus 13w minus 7. It's a cubic polynomial. That's exactly right. What's the leading coefficient? Constant. Degree. The only thing I will caution you here before I set you loose. Actually, I got to show you one little thing with dividing. If you have something like this is still multiplying. This never distributes, remember? Never. So this says do 2x plus 5y 3 times. Now, when you multiply, never multiply more than 2 at a time. Always multiply 2 together, simplify, and then multiply to the next. In other words, I'll do these two, get it down to a simple answer, and then I'll take this answer and multiply it to this one. Don't do more than 2 at a time. We will spend multiple days dividing polynomials. But tonight, you should be able to divide by a monomial. And I'll show you exactly what I mean, and then I'll stop. A lot of this is review for you, should be. You do. You do. This was supposed to be your intro lesson to polynomials. But remember, we did a little review yesterday of some Algebra 1 stuff.
Yeah, it's really good.
So let's say I have something like 30 C8D3 minus 36 C6D2.
Wait.
Here, why don't you hand these out?
Question.
We're stopping at 20 on the homework.
Do we
by the way.
actually divide like the 30 and 36?
Oh, no, we don't have to stop at 20. We can do them all.
Do we actually divide the 30 and the 36 and all 5?
Yes, yes. So here's what we're going to do. And this only works when you're dividing by a monomial. In other words, there's no addition or subtraction in the bottom. I'm going to split into separate fractions and simplify. Well, I'll have 3 different things that I'm adding together. So I'll have this. So 30 C8D3 over 12 C squared D. And then I'll have minus 36 C6D2. And everybody gets the same denominator. Now each one of these little individual fractions are a lot easier to simplify. See why we needed to do that little properties of exponents yesterday?
Yeah.
Thank you. Thank you. So we'll look at this fraction first. What can I divide both 30 and 12 by? 6. Logan, sit down, bro. You can't see the board. I can divide 30 and 12 by 6, right? It leaves me with 5 and 2. And then I start subtracting these exponents. 8 minus 2 is, and 3 minus 1 is, Logan. Since my variables are all on the top, I can write this as 5 over 2 times C6D2. Look at the next fraction. 36 divided by 12 is what? 3. Subtract and subtract. 6 minus 2 is 4. 2 minus 1 is, very last one, 6 divided by 12 is, how does that simplify? 3 minus 2, and these just cancel. So this gives me 1/2 C.
Hooray!
That's a little bit harder than